Okay, so this is the DS laboratory, DS labs at hercules.uw.edu, and we have a messy directories. So let's go down to the mass directory. So we will go down to the mass. And there is the bunch of subdirectories, including C++, Clojure, and Java. And so Java, okay, today I'm going to explain about Java, but C++, but if you go down to the Java, and then you will see the bunch of the different source codes. And not, at this time, source.new4 is more stable. Until actually, over the past weekend, I have debugged the debug agent the features. So I think this is the best and stable of the version. Okay. So today's focus is C++, the directory. So we will go up to the the Java directory and go down to C++. So there were two directories, C++ and all the underscore C++. And all the underscore C++ that includes what the previous students actually worked and tried to run the C++ version. It actually includes the very useful code snippets, but the actual implementation is C++. So let's go down to C++. And then under C++, there are still subdirectories. One is the source. The source includes all the math.c++ code. And libssh2 -1.2.4.2 is the SSH library. In Java, we are using JSCH. Let me check with the camera if it's the monitor. All right. So you don't have to worry about libssh2 because it's already implemented. And if you'd like to continue developing the math library, we can just copy everything. This is just I have downloaded the tar file and expanded all the files under this directory and set up some information under this directory, so you don't have to worry about it. Now, there is SSH2 and test, and if you go down to this SSH2, there are some the directories which you do not want to erase. So this is kind of the part of the libssh2. So just keep it. Now go down to the test2. This is the this is what I actually try to play with SSH2 library. So you don't have to worry about it. This is kind of actually at this time this is kind of garbage, but kind of the test program to work on the SSH2. libssh2. So now okay, one more file. The libssh2 compilation.dbuglex. This is the water file that actually wrote all memorandum when I actually installed this program and write the program. So if you download this documentation, then you will see how to reinstall the SSH-lib and also write the program and how to compile. But you still have to worry about it because I include some shell script under source. Okay, so let's go down to source. And here I actually implemented everything under this directory. So first of all, there were two important files. One is make file. Where is make file? Make file. Okay. So this the make file includes all the comparison the scenario. So in this example we have in this make file we will use the G++, so this actually means the G++, and then we are going to compile mass, compile mprocess, compile Web2D, and compile Nomad. At this time, Nomad is not compiled because I have not implemented. So at present, mass and process Web2D are compiled. Okay? So then the program needs mass-based thread and such. Those are the object files compiled from the CPP. And what else? Prefix. So this is the directory pointing to the SSH2 library and also header file. Okay. Then we'll just compile those 4 eventually, but at this time we'll just focus on those 3. Now the target is actually mass and then mprocess. So this is kind of, so what is the difference between mass and mprocess? Let me just now draw the relationship between mass and mprocess. So you are sitting here. So this is Hartree. And from here, mass is running, and this mass is actually used SSH2. This the contact with the port 22. So at the destination, we have SSH2 daemon process. And this daemon process will launch a user process, which is mprocess.
So question, the SSH2 daemon is started up whenever they boot Linux?
Yes. Okay. So yeah, actually, yeah, right.
It's
so
always
SSH
running.
daemon are the common daemon, which is running everywhere. So mass and this is mprocess. And then once SSH readings is established and the mass is launched, and there is, so as we have studied in 430 or 533, such connection, this is the secured TCP connection. And when the daemon process creates a child process that overrides itself to the mprocess, this TCP is inherited. So the mass process running local to the user and mprocess running remotely are connected with this TCP. So how this TCP is connected to the mprocess is, the TCP is a dual connection. So data will be sent and then provided to the standard in. So mprocess will read the data from standard in or CDN. And then whenever the end process writes something to standard out or C out, this will be going back to the mass process running local to the user. So this is the relationship between the mass and end process. Okay. So this means mass should include main function. And end process should also include main function.
And it is true that end process is never loaded on the original machine. Right?
It is true. It is true. So the mass process is actually is kind of a superset of the end process. So do you have any questions? All right. Then the next thing is let's look at the master CPP. Before looking at the master CPP, I have already created the run.shell. This is the shell script to execute this mass program. So you have to say export such and such that this is the website SSH to the class, and then you will run that mass. And then the mass library needs, actually this is kind of very dangerous. So in the future we need to update. But so here this is the user account at remote computing node. So in this case we're using both DSLab account. DSLab account, and then DS1AB-302 is the password for this DSLab account. And then you also need to read machine file.txt, and 12341 is the port, and 5 is the 5 processes, and 4 is the 4 threads. Okay. So now let's look at the machine file. Machine file.txt actually enumerates all remote processes, not local process. Since we are executing the main program at the address, please do not include packets. So all node 0, 1, 2, 3. So this is kind of the different from MPI. Some of you actually have taken the my 434 or 534 message passing interface. So our kind of the architecture is kind of based on MPI communication. In MPI, you also need to include a local host name. Do you remember? But in our case, since the biggest SSH, because of the biggest SSH, and we do not want to include any complicated feature, so we decided, okay, just include all remote computing nodes. Okay. So eventually, in the future, what I really want to do is, in addition to remote machines, we should include the user account and a password in this machine file, so that we should not include shell script. We should not include the account name and password in the shell script. The reason is, if you run this shell script and if you type ps.a, then shell script command will be indicated on the top or the ps, and which may be picked by someone else. So this is kind of very dangerous, but that's okay, because virtually see the machine which we owned, any other students who are not going to come into the address.
Hopefully.
Hopefully. Okay. All right. So now let's look at the. First of all, let's look at main CPP. This is a user application, not a mass. Okay. So in the Java version, you can actually write Web2D and include the main program, and also places, the extended places or extended agents. But now in C++, the keyword is header file and implementation. So every single big class must be designed in header and implementation, and as well as a driver program like you studied in 342 or Pago 1, right? So driver class header class CPP, and a driver, this is an application. User application that includes main. So in this example, main.cpp is not a part of the mass. This is just a user application. And in this main.cpp is not actually user application, it's just like a test program. Just test program to test call, to test instantiation of the traces, test call, and
Mass init, mass finish.
yes, and also exchanger, and so on. And then I am done with the agent instantiation, but now you need to implement agents call, agents manager. And then at the end, must finish, we'll just terminate remote processes and then disconnect all links. But in C++, even after termination, the main program will keep running. So you can do some, user application can still do something in sequential with the master process and the master thread. Okay. So this program received like we have looked at the shell script. This program read the user account, the password, machine file port, and a number of processes, a number of threads. Those are stored in arguments, right? And then placed in deconverted into every process and thread. In Java, we use integer.parseInt, but in C++, in order to convert string into integer, we have to use A to I. So ATOI or A to I is ASCII to integer conversion program. So argument 5, argument 6, which corresponds to nproc and thr are just converted into integer values. Others are just assigned to arguments. And then we will pass the arguments and a number of processes and a number of threads to the mass unit. So within the mass unit, what mass unit actually does is create this connection and then launch the remote process. And the remote process is just waiting until call all or exchange all or further mass functions will be invoked. Okay. So then in this example, I have instantiated Web2D places. So the Web2D itself must be the class. And then for each, so remote process actually creates Web2D, and also as well as the local process will create a bunch of Web2D. So each is called a place. And each element actually is instantiated given with MSG argument. So this is pretty much the same as the Java specification, right? So, but it's 2.7. I'm sorry, but
the interval and number of iterations.
Let's see. I will check with the place. We will check with the places constructor. But at the very last one, those are the size information. And also in Java, we don't have the length information of the given array. So we have to say the dimension. We have to clearly say the dimension. We need the dimension. So this is a 2-dimension, and so 100 by 100. 7. Let's check with the places constructor data. Okay. And this is the handle. And once the place is created, and then we will get the pointer. So now, after the construction of these places, now we can use the pointer.call, pointer actually directory call, and this means we will, each element will execute init. In Java, this should be dot, but in C++, we have to say wave to the class internal scopes init function. And in Java, we use the call method. The call method receives the function number, the same. We cannot actually directly invoke a given function, because this is possible in C, but not in C++. We cannot directly jump into some method within a method, within an object. So we need the function, the number or ID, and then the message will be given, and also there is the object. Message argument is zero. But now, this is also hectic things. Oh, I also came up with the 7 too. In Java, whenever you pass the object is automatically serialized. So the Java virtual machine knows the size of the object or size of the argument. But in C and C++, we don't know the size. Operating system does not know the size of the object. We have to pass a size. So in this example, message object includes 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, and 7. 7 elements. And here 5. 1, 2, 3, 4, 5. Actually, this should be 6. So I think I should change it to 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. So that's why I have included the size of the argument passed to constructor or call. And as you know, in C++, this is not C++ string. This is a C character array. And in C character array, you need to have /0. /0, this is the end of the string or end of the character array. So we need, otherwise, when we pass the argument through the TCP, and operating system say, okay, one is there, where we can find out the reader. Right. And then we can make a call of the call. Another thing, this is the call for all, returning back the return value from each element. So the first call just count the distributed arguments, and then just call init, call init, call init, call init, call init, call init. However, the main program does not receive any return value. The second one is passing the arguments and then return the value. So invoke the int, and in this example, invoke call or cast, then all so each element returns the value. So each element return values to red bubbles.
And these values have to be cast to a type
Yes.
because they're returned in a generic manner.
Generic actually void.
A void.
In C++, void.
So each user application that's writing a main.cpp, they need to know
Yes.
what's coming.
Right, right. And in this example, let's look at this. Again, core args. Core args is actually includes is integer. So I have to say, okay, this is the size of integer, and then each argument size, and this is the void. This means each the place receives different argument. So you have to pass the array of arguments, each corresponding to a different cell. That's why at this time I have defined 100 by 100 arguments, and just the assign the different value to the different array element, and each array element will be passed to the different place. And of course, the return value will be collected in the red vowels, and each red vowel element includes a different value from a different place. Okay. All right. The next one is, of course, I checked the value will be coming correctly, so I checked it. Then the next thing is exchange all. In exchange all, destinations. Okay. So in Java version, actually this is pretty much the same. In Java version, you also have to define the neighbors, and in the vectors, the same. I have included the C++ vector, and each the vector element should be integer array. So here, this is the nose. Generally, this destination is the relative distance from each element. So 0, 1 is 0, 1 north, and 1, 0 means east, 0, minus 1 means the south, and minus 1, 0 means the west. So I declared all those, and then I just push into the destinations. Thereafter, this program actually called exchange all. Each element will invoke its neighboring cells exchange test function. Okay. Then from the Java specification, each cell includes in messages and out message. Did you read the mass specification? This is pretty much the same. So each element includes in messages, out messages. So in messages will receive the return value from the neighboring cell. So that's why now I call check in message. So each message just print out the message, what each cell has received from its neighboring cells. That's all. And this is actually, again, pretty much the same as the new places, but new relations, the handle, and agent class name and arguments passed to each agent constructor. And Web2D is because the agent needs to stay on the places, so just pass the Web2D places. And 5,000 means we would like to instantiate 5,000 agents. Any questions? Right, good. So now let's look at mass base .h. Mass.h includes, so mass.h the actually will be accessed by both mass and the process. Okay. So
Mass base or
mass base, mass
Mass
base.
base.
Mass base is inherited by mass and also M process. What data structures have been included? Okay. So the mass code, 1, 2, 3, 4, 1, as you look at in shell script, and current directory, and host name, my local host name. So this means if each M process is running at M0, 0, 1, 2, 3, then host name actually includes the local host name, and my PID. My PID is local host is process 0. And the remote host is 1, 2, 3, 4, 5, 6. No. And system size, the number of processes. So if I say five computing nodes, like M node 0 to 4, 0 to 3. And PID 1, 2, 4, and 0. So this means the system size becomes 5. And logger, this is quite important. The reason is local machines can print out a message through cin, cout. So cin will be coming from the keyboard, and the cout is going to the monitor. So you can actually put some cout to check the status of the mass.cpp or some debugging information. But if you look at the M process actually is using cout to communicate back to the local process. So if you write some error messages into cout, then the local process gets mapped. So generally, remote process need to write the log file. So instead of the sending back the error messages to the main program, each remote process writes the error messages or set of messages to the local file. However, of course, in many the cluster systems, including Hercules and nodes, they are all connected to network file systems. So we cannot use the same file name. If we use the same file name, then all remote processes will mix up the contents onto the same file. So generally, this log will identify, use this PID, logger version file 1, 2, 3, 4, so that we can check which remote processes, the debugging and the status information through the different file. Okay. Now, the next one is quite important because this is still that of Java version. Message map, agents map. We usually would like to instantiate multiple places. So multiple places means, say, Wave2D and also CFD or Nomad, Sharp, ANS. So we would like to maintain the different kinds of places and different kinds of agents. So those agents are stored and maintained in places, stored in agents map. Different places are placed in the places map. So, and then the next one, DLL map, a collection of DLL classes, because in Java, dynamic linking is quite easy and handy because you don't have to worry about it, because whenever you'd like to launch the new class, the Java will just read the corresponding file, right? So if you say new ABC in Java virtual machine will access ABC.class automatically. So that's quite convenient. That was quite convenient in Java, but in C++, we have to say, if we'd like to access ABC, then we have to go to abc.all, and for this purpose, I have implemented DLL function. And once we have find out corresponding class, I included the corresponding object file into DLL map. So from the next time, I don't have to go to operating system DLL open function. So that's why we needed the third map, hash map. Okay. Remote exchange request. I'm going to explain about it later. And other is the request counter, current policies. So because among many places, given call or exchange of the request, we actually say, okay, this is what we are working on. So current places and current agents and so on. So all those are the places or agents which we are working on. Action type. So, like I have said, once the empty mass unit is called, all remote processes are launched. However, they are blocked upon a read. In operating system 503 or 533, we studied about the read function with the blocking read. So all remote processes always will be suspended at read function. And then whenever call all exchange all has been called, then such request will be sent, and so that all remote processes and processes will read this action and then start working on call all or extend all. Manage all. And then, of course, there is some critical section, so I have defined some critical section. Log block means this end process and local mass are multi-threaded. So after init, threads are created, multiple threads are created. Those threads will write to the log file. Without log, they messed up again the log file. So that's why I needed log. request walk is again, I thought I thought, but let's see later how request walk is handled. Okay, so far do you have any questions? Okay, so interestingly, in C++, in Java, how can you declare static variable? I mean, generally, you can say class, ABC, public static, int such and such, so that you can actually instantiate static variable. But in C++, static variables are not allocated. That was really very, very tricky. So you have to say, you have to allocate static variable like a global variable. So those are all global variables because they're not actually. So those are, for instance, mass port. Coming back to the H. Okay, so here, look at this. I declared static mass port. However, all those static are not allocated within the actual object file. After declare in the header file, in the implementation file, you have to actually allocate all those static variables. So that's kind of very tricky. You have to again allocate in the implementation, otherwise compiler will really complain. Okay. Then we have a bunch of functions. Rather than talking about those components, now let me go to Maths so that we can see how those components will be used. Right, so this is the very first function executed by the user program Maths Unit that includes arguments, number of processes, number of threads. Right, then verify the arguments like a username, password, and a machine file, and a port. And number of processes, number of threads. Now, we'll go to read a given machine file. So first of all, read the machine file, and then check all remote machine IP address. So read it, open a machine file, read it line by line, and put it into the host as the vector, and close this file. Okay. So nth block, number of processes should be one larger than original host, because hosts actually include all remote processes only, and we need this local machine, so we just add one more. And so then we will say system size, this is the same as n block. Then initialize mass-based constants and identify the current working directory. So here now we can go to the mass base.
the Java version, I don't remember that machine file.text was tied to the number of processings. I thought we had machines listed, and if mass was told to use 3 processings, it would go out and get the first ones that it needed. But
Right.
here you're really relying on machine file.txt.
Actually, system size is also adjusted later
Okay,
because nproc actually,
okay.
let's see, nproc is look at this. nproc, if nproc is larger than host size, then nproc is adjusted to the host plus 1. And so if nproc is smaller than or equal hosts, then actually it doesn't change. So in this case, we can actually make sure that nproc is actually does not change. Actually does not change. So unit mass place, right? Unit mass space. Unit mass space actually just initialize all local static variable, host name, PID, system size, mass port, and so on. And then initialize log variables, and then just read current working directory. Current working directory, that's all. That's all. Okay. Then we will come back here. Launch a remote process. So the remote process ID starts from 1 rather than starting from 0, because 0 is assigned to the local machine. And then we will establish the libSSH connection within this folder. First of all, from host name, we will retrieve canonical remote machine name, and then the get host by name is a function to interact with DNS, and then we will get the IP address. Once we get IP address, then we will actually get the actual formal name. So in the previous week, we actually looked at the mnode 0, mnode 1, 2, 3, but from this function, we will get mnode 0.uwb.edu. So just like to make sure the formal IP address. Okay. Then establish the SSH2 connection. So due to establish connection, this is the I'm not going to explain, but this actually code came from Narayani's code. I just reused Narayani's code. This actually established the code and the handshake with the security, the cryptography, and then get the TCP connection. So after going through this code, then we will get the SSH2 connection. This is the TCP connection, and then now remote processes program. Here I create remote processes program. So current working directory, because all computing nodes are supposed to connect it to the network power system. So get the current working directory so that we also want to run the process on the same directory. Generally, SSH connection, establish the connection, and then the SSH daemon will the forward charge process, but this charge process is launched under home directory. This machine is running out under math/C+/source, but now this game process is running till the DS lab. So quite different. We also would like to launch this new process, math/C++source. So this current directory includes this working directory. And under this directory, M process. This is the program name process. And then include current working directory, the command, the space, and current host name, and so on, everything. And then this converted into the string. And now, using this connection, just called launch mode process. So SSH2 daemon will now launch M process at remote computing. Once it's launched successfully, then we instantiate M node, which is pretty much the familiar to you. So
we take a picture of that, or is
yes,
it
yes, okay. So remote process actually interact with the local process through CIM and CR. And how about the local process? Local process actually creates M node. And so within M node, there is the TCP connection, the output, and also input. So if you have other machine like this is M node 1 and node 2. Then we will have another M node. So in the local computing node, the math of TCP includes a bunch of M nodes, each corresponding to a different remote M process. So create M node, and the M node includes the remote host name and remote process ID like 1, 2, 3, 4, and then connection to that remote process. Then the next thing is, like I have said, so we run the M process, remote process, create M node. The next step is, of course, we are going to launch local threads. So here, initialize threads and number of threads, so we will create the given number of threads here. Then initialize set to synchronize or say processes. Okay. So this is what the Java version didn't include. The Java version, actually, I have already included this past Friday. So Java version actually sent the command to say, okay, instantiate and process the invoke call all, invoke exchange all, but the master process actually didn't wait for the completion of each command. This actually messed up. And some process is working on the previous command, the next process is working on the next command. This really made up the very complicated situation. So nowadays, Java version, both Java version and C++ version actually always include acknowledgement. So mass process is once, each mass process send acknowledgement saying, I'm a creator. So here, receive the message, and then check if it's acknowledgement, and if it's acknowledgement, that's okay. And then we're done. So this is the creation of the mass. Create the mass unit. Okay. So initialize thread, if you'd like to see the initialize thread, this should be mass space. So first of all, check the number of threads. If number of threads is 0 or negative, then we will compute the number of CPU cores, or just the number of threads is positive, then we will say number of threads. However, at this time, get cores is empty. I have not yet implemented. Right? Then we will call threads reserved such and such, and so we will actually reserve the thread in array. And then here, initialize m threads. So this is called, each thread is called m thread. So initialize m thread the shared variable, and then launch m threads. So go down here, and then m threads 1 will be executed, and then create each child thread, and then put the child thread into the thread array. So once they are instantiated, each actually starts from the run method, like a Java method, and then reference is placed into threads array. So this way we can actually give some instruction to each thread through threads array.
So in the mass.cpp, where it calls initialize threads, should it look at the value returns? Because you return a bool instead of assuming it's initialized? Or
yes, if it's not, it is always return true.
so it only returns when it's true.
Yeah. Because if something occurs, then the process actually is terminated. So rather than waiting for the return value, the program itself is crashed at this time. So, that's all. Then the thread is created, synchronized with all processes, and that's all. So let's look at the, are you tired? Should we have a 5-minute break?
Stand up and stretch.
Yeah. Yeah, let's have 5-minute break. Okay, okay. So let's continue. All right. So now we can just quickly look at how to terminate the remote processes. So let's finish. Okay. So first of all, threads are all the, like I said, remote MNOs are always deployed upon a read. And how about the threads? Both the local and remote threads, they're actually waiting on wait. this is Java in C++, I forgot. Let's see, called wave, right?
What is it?
Conditional wave, on wave. P-thread on the wave. So all threads are waiting a P-thread on wait, and then, so by calling a resume thread, they just all resumed. And when the reason why it's really accurate, my palm is got really sticky. This one is really sticky, so that's the reason.
It's weird.
Okay. So then, that's why I actually decided to bring my pointer. So here, when resume the all threads, I just pass the status terminate, and once this terminate is passed, and then the threads are the awoke, then they just check the status, and then they just get terminated. And the barrier threads, 0, then actually when the threads are done, then just the main thread will also will be awoken, and then we will go down to the connection termination. So for each M thread, because M node actually includes the all connection. So for each connection, the send a message saying that finish, so that each M node receive finish and terminate it. And then before terminating it, then they just send acknowledgement. So the acknowledgement comes back, and then that's all.
And of course, there's garbage collection that happens. Yeah.
Yes, garbage collection happens. So here, look at this. We delete M.
Delete M, yeah.
Yes. All right. So what else? Various read. So barriers. So various waves here. This the actual implementation here. So just the just receive the message. That's all. And then delete them. Right. That's the init and then finish. Do you have any questions? That not really complicated, right? Very, very straightforward.
Well, for me, who's been hearing this for a year, it's not too bad.
What do you think? Is it okay? The reason why I'm asking you is CSS 533 homework assignment number 2. I'm thinking let students to use it libssh2. Kind of very interesting. So the launch remote processes that work all Java space servers. And so each server actually maintains a different portion of the hash table, and then the client says, I would like to read such and such object, and one of the servers said yes, and then they'll return the other contents. So this is the homework. Thank you. Right. So then the next one, places. So coming back to main, once we have created, then we can actually get the places, and then we can make a call of call all. So now let's look at the places. Places, of course, includes the constructor and call all, extend all, and then as the utility function CSRF, which is pretty much the same as Java. CSRF if you look at the standard version. And then this includes the inherit places space. Because all process, remote process only needs mass base place space. Because actual task at CPP, actual places at CPP are all executed in the main program or local process. So only the subset would be shared between the local main process and remote main process. Okay. So let's look at the constructor. So here we need the dimension, right? Dimension, and that's the this is the C++, the C notation. If we would like to include multiple arguments, but we don't know yet the number of arguments. So if we say 2, then the compiler expects 2 more integers. Right. This is what I didn't teach in 342, right?
We actually just went through this in 343.
343. Okay, good. So how was the lecture about Mike Stark? Is it okay?
I think he's getting better.
Getting better.
I just hope he catches up with the syllabus.
I see. He has been sick, right?
Yeah, I think so.
I see. Okay. All right. Then, so first of all, using a beam, then we will just create the integer array size. So this is the same as the Java size. And then we will read the rest of the arguments and then just initialize the size. So if we, I think I should clean up. Now just focus on basis. So if we say play is new handle 1 way to the, and then let's say 6 to 100. Those 100s are stored in size of 0, size of 1. So that you can actually say, instead of 100, you can actually say 200. Then this means 100 by 200, the two-dimensional array is created. So the size is initialized, and then we will call init all. Init all is, since the places constructor will be called at the master mass process and all and processes. So init all is actually called by all processes. And then init master, this is only executed at the local master process. So let's look at init all. So this is in places base dot cpp.
Places.
Oh yeah, places. Thank you. Init all. So places base. This is called by each end process. So, just say this is master, this is strings. In the master, we will call new places. In string, we will call new places base. So in either case, the size is actually initialized, and then init all will be executed. So let's look at the init all. Okay, so this is kind of very tedious work to write a file locally here. So mass-based log. This is the function to write the string to the file. How would you like to write the string? Generally, this log function receives only the C string. And first of all, you have to create entire message. Yeah, so entire messages, and then also create everything. So first of all, the C++ STL includes output string. So just declare it, and you just put everything onto the convert, and convert it into the string, and pass it to the log file. This is really very, very tiring work, but this is only good for the C++. So, unfortunately. Yeah. Then we will go to now the fun part, DLL class. So here we create DLL class. This actually includes the Wave2D is now loaded into the memory. So this is done by DLL. Both of you guys actually don't know what is the DLL open, but 4 of you actually have taken 503 and 430. You must know DLL open, right? Or forget. So DLL open. So if you go down to the DLL class, so just call DLL open. So first of all, Wave2D or all class must be located in the current working directory. So current working directory, and then the class name, and then call DLL open. So this is the operating system function. So the binary code loaded into the memory, and then instantiate the object. So at this time, just we loaded in Java, we loaded into the bytecode, but we have not yet instantiated it. So here, then we will instantiate one object. Okay. Okay. Then, so coming back to here, we have instantiated, and then insert this Wave2D object into the DLL map. Okay. All right. Then calculate lower boundary and upper boundary. So because if we create, okay, let's assume that we are using only 2 processes. One is one master and one slave, and 100 by 100. So this means we will create 100 by, actually 50 by 100, and here 50 by 100 array. So by coding here, calculate lower boundary and upper boundary, we will just say lower boundary here and upper boundary here, and how can I calculate lower boundary, upper boundary? Okay. At this time, we have created 100 by 100, but just think about, just expand this 2-dimensional array into single-dimensional array. So array starts from 0 all the way to 9,999. So what was divided? So in the master process, this should be array 0 to 49.99, and this should be 5,000 to 99.99. So 0 is the lower bound for the master, and 499 is upper bound. So calculating the boundary for each process. Now we instantiate each place. We instantiate it, and then from the dimension. What is the dimension? For instance, here this is the 2-dimensional and so on. Then index is, by calling index differs for each place. Okay, so here we instantiate each element, and then calculate index, because each element, for instance here, includes index 0, index 1, may correspond to 49, 30, 21, whatever. So this means x-axis, y-axis. So index is calculated, and then initialize each place's index with this calculated index. And a global array index, that global array index is actually converting, say here, 49.99 is converted into, say, 49.99. So this is converted and initialized. That's all. Get global array index. So this is how to convert global, the single-dimensional index into the 2-dimensional index. Algorithm is the same as the Tim Chuang's Java version. I just brought it from Java version. Okay. All right. So this is the how to instantiate each object. So in review, download actually the dynamic linking from the disk into the memory, and then register as a class, and then instantiate each element, initialize each element's index. Okay. So coming back to places. Sometimes this is so slow. So, master, after the master, first of all, instantiates its own region of the places, and then it calls init master. Init master starts from here. So convert size to the vector and then create a list of all host names and the master IP name. So those are actually creating create all 3 byte name. Message is created and then 3 byte is created and then create a message. So the previous one is actually the just show, okay, this is I am such and such the machine, and then I have such and such host, and then I also create because in this example we have only one slave, but if we have many slaves, then each slave actually does not know which slave is running on which machine. So we have to tell them the all collectionable machine names. So that's why here I have created the collectionable machine names. And then we said we're going to send initialize message. So initialize message will be sent from the master to each slave, and slave is waiting working read, and read now realize, okay, this is places initialize, so this calls the places base constructor. Okay. So the message is sent, then set hosts. Set host will be called, this is another different strategy from the Java version. In Java version, so here this is the master, and slave, SSH link is created, SSH, the lib SSH connection is created, and then for exchange all, they also the slave also needs to create the inter-slave
Direct connection.
direct connection. And this direct connection in Java version is created dynamically. Dynamically means when upon they really need to communicate, in this version actually create dynamically, but this actually complicates the tracing the program. So I decided, okay, anyway, we will create this connection eventually. So at the very beginning, why don't you just create everything? So I just created everything in this set host. And then call various slaves, so make sure that all slaves actually create connection, and we synchronize. And then after synchronize, this means all processes have created its own places and synchronized, and then just now register the places map. So the places map receives handle 1 or 2 or 3. Here, in this example 1, and this the places object. So that's all. Any questions? So let me just explain about mprocess.cpp, then we should be done, because this is too long and we still have tomorrow's sessions. We can look at the Java version tomorrow, but if time allows, then we can come back. So So end process is launched from the SSH daemon when the SSH TCP connection is established. So this means the end process also the directory starts from the main program. So main program and receives all current such and such all information and go to this current directory, because when the SSH daemon runs the process, it's actually started from the home directory. So now switch to the current working directory, and then instantiate end process, the process, and then launch end process at each project. Where is that process? Here, and then what we'll call start. So create object, and then what we'll call start function. So let's look at the constructor. Constructor receives all the information and call init mass base. So this init mass base is called both master and slave. Just at the master side, what we call mass base. And then here, now create the logo file. Create a logo file, and then initialize thread. So start threads at each the remote end process. That's all. And then what will start? We start from the start function. Start function sends acknowledgement back to the master, because we also would like to handshake at the user level. And then each end process will go into the while loop. The first thing is receive message. So receive message, what receive message does is here. So here, read from 0. 0 means standard input, right? So 0 is the standard input, 1 is the standard output, 2 is standard error. So read here, and the read is just block here, and read a message, and create the message, deserialize. In 533 last week, we studied about object serialization, deserialization, because C++ actually does not do this. So I had to create the function. This is the really ridiculous and tedious work, and very, very bug prone, because I have to remember what kind of data has been sent, serialized, and what kind of data has been deserialized. So, message. Serialize just the for each object, count the number, the size of the elements. Thereafter, once counted, to sum up all the message size, and then create a contiguous space, and then convert each object and put into this contiguous space.
So you have defined a message that's going to have a certain format for every message, right?
Yes. So here, place initialize. Place call return object. Place is exchange all.
Oh.
Right? So this was, I think, 1/3 of my entire work for this implementation. The Java, everything is just automate everything. That's why Java, C# are really powerful for distributed parallel computing.
But if you compare the performance of that versus what you have here,
Yes. Yes, that will be done really fast. So, coming back to the process. So the each end process is blocked until the new message will come in here. And then once new message is delivered, and then look at the message, the action. And then jump to each action type. So if it's finished, then resume threads and kill them, and then send back acknowledgement. That's it. If it's initialized, then create places by calling places base. Places base and handle questing and so on. And then here set host to create interstate links, and then send back the acknowledgement. That's all. So we're done with the init, finish, and places construction. So if time allows, tomorrow I think I will mention about Coro, Exchange all, and that's all. And also we will look at the Java program. I'm tired. But we still have 2 more hours
in the class.
for 5:33. So. But CUDA version, you don't have to worry about this, the message send, message request, serialize, deserialize, because everything is done within a single computing node.
Yeah, I'm realizing that my task is on one part a lot easier than I thought it was going to be, and then a lot more complex.
But eventually, we're going to have